It was so awesome. So at least there's this like milk and I was like, yeah, there's about in this area and then they're like, this is pretty oops. Still yeah, but it won't like no. It's the first like I do ask that you be patient and today I'm still basically the reason I wasn't here on Monday is I ran fever all weekend, and it wasn't until late Sunday that my fever finally broke. So I didn't want to take a chance since I didn't know if it was going to stay broken or not, and that's why I wasn't here on Monday. But I'm still, my voice is not 100%. So I am going to be a little bit quieter than normal. I would try to speak loud enough to be heard, but just so that you know, this is about the maximum without me starting to cough that I can do. So I'm trying to manage it all. Because I was ill, I have not gotten your tests graded. I will have them back no later than Monday. I don't expect it to take me long to grade once I can sit down and do the grading, but it just has not happened as of yet. So expect your exams to come back on Monday. Now, normally they will be back within 1 week. This is going to be an exception, and it's simply because I wound up sick and not being able to do any, and I'm still trying to recover. But normally they will be back within 1 week of taking me today. So to give you a little bit of insight, number one, today we're going to finish up our conversation about density, which I started on Wednesday of last week. We will do density, and we'll look at density as a conversion factor. After we finish with density, we will finally move into, we'll do a mixture from there on of math and chemistry, but we'll finally really get to start moving into the chemistry. So today I'm going to do a bunch more math. We're going to do conversions, but we're going to use density as the conversion factor. And then on Friday, as of right now, this could change as of tonight, but as of right now, Dr. DeRocher will be with you on Friday, and he's going to start going over the periodic table and the arrangement of the periodic table. So we finally get into the chemistry, which I'm sad that I don't get into, because that's where I start getting really excited, is when I get into all the chemicals. I like to play with chemicals. So, and then we will continue on Monday. We will discuss the elements. We'll go into greater detail with the elements, get into the number of protons, neutrons, electrons in an atom of an element. Then we'll get into what is known as the average atomic mass of the element. So we will bring back some calculations at that point, but it's going to be all about the elements at that point. So we'll really start focusing on a specific type of thing. And we're going to spend some time on our elements. Once we spend the time on the elements, then we'll start talking about those elements in terms of ions. And we'll move off of elements into developing compounds. And we'll start learning to name compounds. And we'll talk about compounds to a great extent. And so we're going to really start focusing our attention starting Friday on the chemistry rather than all the little details that go into some of the calculations we do as chemists. We're still going to be applying the information that you've been learning. It's just, it's not going to be the singular focus. The chemistry is going to be the primary focus, and we're going to use the math to get to something. Any questions before I get started with the density? So as we were discussing last Wednesday, when I go to discover what something is comprised of, one of the things I can use to evaluate that material and to determine what that material is composed of is the substance's density. And so we talked about density. Density is equal to the mass divided by the volume. And we spent our Wednesday focused on calculating the density of the material. But density can also be used as a conversion factor. So, when can you use density as a conversion factor? Huh? When you have mass and volume. You'll frequently use density as the conversion factor when you want to or when you need to convert between the amount of something and its volume. Now, before we get into using density as a conversion factor, I want to outline the mental process in getting density ready to be a conversion factor. When I see something such as antifreeze has a density of 1.11 gram per centimeter cubed. If I simply write density in this manner, gram per centimeter cubed, I don't readily see the conversion factor. So this is what I mean by mentally preparing to use it as a conversion factor. Instead, what I'm going to do is I'm going to take that 1.11 gram per centimeter cubed, and I'm going to rewrite that into its units. What does this mean? It really means 1.11 gram of antifreeze per 1 centimeter cubed of antifreeze. That's what it really means. If I see acetone has a density of 0.7857 grams per milliliter, I rewrite that in preparation to use it as a conversion factor. What it means is that acetone is 0.7857 grams of acetone per 1 milliliter of acetone. What this allows me to do is, if you'll recall, on all of your conversion factors that we've used, there was a numerator and there was a denominator. In the numerator, we had 1 unit. In the denominator, we had a different unit. By taking and rewriting the density in this format, what I've done is I've changed it into something similar to what I'm used to seeing. I'm used to seeing a number with 1 unit over a number with a different unit. I've changed it into the conversion factors that I'm used to seeing. Same thing with the grams per milliliter. It's, instead of just written out in this format, I've changed it into what I'm used to seeing. And that's going to help us when we start putting this into a and using it as a conversion factor. Now, the other thing you need to know about density is we can write the density in the format that we have it, or depending upon what we remember as we do conversions, it's always been about what did we need to get rid of. what unit do we need to cancel out? In some cases, you're going to have to flip the entire density over in order to be able to use the appropriate units to cancel out. And you can do that. But you got to flip the entire thing. So let's just look at some examples. What is the mass in grams of 226 milliliters of antifreeze? Okay. Step number 1, identify what we were given in the problem. We were given 226 milliliters of antifreeze. Step number 2, identify what you want to solve for. We want the mass in grams of our antifreeze. Step number 3, identify a possible conversion factor. In this case, because we have volume and we have mass, the conversion factor will be density. We have volume and we have mass, so the conversion factor is density. And we said a few minutes ago that 1.11 gram antifreeze is in 1 centimeter cubed of antifreeze. Now, to be able to, again, why am I using density? Because it has mass and it has volume. It's the only conversion factor we know that has mass and it has volume. We can't go to our tables that I gave you prior to exam 1 because they don't have a conversion factor that has both mass and volume. The only thing we have that has both mass and volume is density. So we've got to use the density. Now, to be able to use this density, I noticed that my volume unit is in centimeters cubed. So I'm going to have to, and the volume unit I was given though was in milliliters. So I'm going to have to also use the fact that 1 milliliter is equal to 1 centimeter cubed. So I've identified what I was given. I've identified what I want to solve for, and I've identified possible conversion factors. One of those conversion factors was the density because I had both mass and volume. Now I begin the problem. You always begin with what you were given, which is the 226 milliliters of antifreeze, which I'm going to just put as AF for now, instead of writing out the entire word. My first conversion factor needs to be able to get rid of milliliters. I have milliliters in the numerator, so in order to get rid of milliliters, I've got to have milliliters in the denominator. So I'm going to put the 1 milliliter in the denominator and then the 1 centimeter cubed in the numerator. The milliliters had to go in the denominator so that they would cancel out. And you're left with centimeters cubed. Now that I have centimeters cubed, I need a conversion factor that allows me to go with centimeters cubed perfectly onto the mass. And that's where the density comes in. I will put the 1 centimeter cubed piece of the density in the denominator and the 1.11 gram in the numerator. The centimeter cubed had to go in the denominator so that the unit will cancel out. And I'm left with grams of antifreeze. So 226 times 1.11 is 250.86 grams of antifreeze. Looking at our significant digits, you had 3 significant digits in your original number. 1 centimeter cubed to 1 milliliter is an exact quantity. So these have unlimited numbers of significant digits. Your density had 3 significant digits, and the centimeter cubed in the denominator would be an unlimited number. So the minimum number is 3 significant digits. So my answer should have 3 significant digits. So I would record this answer as 251 grams of antifreeze. Questions? So what volume in liters contains 4.2 kilograms of antifreeze? We identify what we have been given. We have been given 4.2 kilograms of antifreeze. We identify what we wish to solve for. We want the volume in liters. Because I note that I have a mass and a volume, the next piece is to figure out conversion factors. Because I have a mass and a volume, my conversion factor is going to be the density. So one conversion factor is going to be 1.11 gram antifreeze is in 1 centimeter cubed of antifreeze. That has got to be one of the conversion factors I'm going to need. Now, other things though that I note is that I'm starting out with kilograms, and in order to do this, I need it in grams. Well, kilograms, grams, that means that I'm going to use my metric prefix conversion factor with 1 kilogram is equal to 1 times 10 to the 3rd grams.
I also realized that in doing this, my volume unit, I need in liters, but I've got it in centimeters cubed. So I'm going to need some conversion factors here. So one of those conversion factors, the only one that I know that has centimeter cubed and a metric unit, is 1 milliliter is equal to 1 centimeter cubed. You may not come up with all your conversion factors. We'll find out if I got all the conversion factors when I actually try to do the math. But you can start to come up with your conversion factors that you're going to need. So I've come up with some conversion factors. Let's start the math. I'm going to start with the 4.2 kilograms. Of antifreeze. My very first thing I got to do is get rid of kilograms. So I find a conversion factor that has kilograms. So I'm going to be using my metric prefix conversion factor. Of that metric prefix conversion factor, the kilogram is going to go in the denominator. It had to go in the denominator because I need it to cancel out, leaving the 1 times 10 to the third grams of AF in the numerator. Now I need to get rid of grams of antifreeze. Here's where I can use my density. But you'll notice that grams of antifreeze is in the numerator right now. In order to get rid of grams of antifreeze, I've got to put grams of antifreeze in the denominator. So I'm going to have to flip my density. I'm going to have to put the 1.11 grams of antifreeze in the denominator with the centimeter cubed in the numerator. Notice I just flipped the entire thing over. And I did that because, again, I have to cancel out grams of antifreeze. Now my centimeter cubed. I need something to get rid of centimeters cubed. That's where this milliliter to centimeter cubed can come into play. Of that, the centimeter cubed goes in the denominator and the milliliter into the numerator. Again, the centimeter cubed had to go in the denominator because I have to cancel out that unit. But I haven't answered the question yet. Because the question didn't ask for milliliters, it asked for liters. I didn't have all my conversion factors. How did I know I didn't have all my conversion factors? Because I haven't gotten to the right unit yet. In order to get this to the right unit, I needed another conversion factor. I need the fact that 1 milliliter is equal to 1 times 10 to the minus 3 liters. Of that, I did put the milliliter in the denominator so that the milliliter would cancel out, leaving me liters for the numerator. Now I can do the math. And when you do the math, you get 3.7838 liters AF. We've got to pay attention to our significant digits. The first number had 2 significant digits. The second number was a metric prefix conversion factor, so it's an exact quantity. Our density had 3 significant digits. 1 milliliter to 1 centimeter cubed is an exact quantity, so it has an unlimited number of significant digits. And our metric prefix conversion factor also is an exact number with unlimited. So the measurement with the fewest had 2 significant digits, so our answer should have 2 significant digits. And therefore, we would report this answer as 3.8 liters of antifreeze. Okay, I walked it through, but I know that people were writing while I was talking, and therefore may or may not have picked up on the little nuances. So I want you to look at the problem. Yes, conversions can have any number of conversion factors. So far, we've only played with 2 max, maybe 3. This one had more. But the concept of a conversion stayed the same. What I did is I started with what I was given. 4.2 kilograms. I figured out what I needed to solve for. I needed liters. Kilogram is a mass unit. Liter is a volume unit. The only conversion factor I know out there that allows me to go mass and volume is going to be the density. But in order to use this density, I couldn't use kilograms. I had to have it in grams. So I went and got my metric prefix conversion factor. In order to use this density, I didn't need liters, I needed centimeters cubed. So I found something that had centimeters cubed and a liter in it. In this case, it was a milliliter. You may or may not find all your conversion factors. But if you're doing a conversion properly, you will know whether or not you have them all. Because you will make sure that your unit cancels out each step along the way until you get to the desired unit. So the only reason I knew I didn't have all the conversion factors is because I did not have a way to go from milliliter to liter. So I had to go get one more conversion factor to be able to do so. Questions? Let's look at another example. What is the mass in grams of 12.55 milliliters of acetone? Okay. What was I given? I was given 12.55 milliliters of acetone. Which I'm going to just label as ACE. What did I need to solve for? I need to solve for mass in grams. The only conversion factor that I know that has both mass and volume is the density. And the density was 0.7857 grams of acetone per 1 centimeter, per 1 milliliter of acetone. Okay, so beginning this problem, 12.55 milliliters of acetone. I need to get rid of milliliters of acetone. So the milliliters of acetone have to be the thing that goes in the denominator. So I'm going to use my density just as it is because the milliliters of acetone are already in the denominator. And the 0.7857 grams of acetone will go in the numerator. We used it just as it was because the units are canceling. Perfectly wonderful. And we're ready to do the math because that's what we were asked to solve for. When you key this into the calculator, you get an answer of 9.860535 grams of acetone. Significant digits, our original number had had 4 significant digits. The density we were given has 4 significant digits over an unlimited number. And so the answer should have 4 significant digits. So the answer should be reported as 9.861 grams of acetone. I want to give you a moment to try this one. You should have gotten 11.6 milliliters of acetone. Basically in this one, again, I was given 9.12 grams of acetone. I was asked to solve for milliliters of acetone. Anytime I've got mass and volume, I'm going to use the density. So I needed the 0.7857 grams acetone is 1 milliliter acetone. I started with the 9.12 grams of acetone. But and then I needed to flip my density because I had to get rid of grams of acetone. So I had to put the gram portion in the denominator, leaving me the mill portion in the numerator. And therefore, and then the number of significant digits, you had 3 significant digits in the 9.12 grams of acetone. You had 4 in the density with an infinite number on the milliliter piece. So the one with the fewest was 3. So our answer should only have 3 significant digits. That's why you recorded as 11.6. Questions? Yes.
Okay, so I may have missed something, but I'm trying to figure out where you're getting the 0.7857.
That has to be given to you. That has, you'll have to be given the density. So it was way back up here at the beginning. I just gave you some densities of antifreeze and acetone. But you'll have to be given the density because for every single thing out there, it has its own unique density.
Okay.
So you're not going to be able to look it up on a table.
Okay.
You'll always have to be given the density because every isopropyl alcohol has its own density. Water has its own density. And so you're always going to have to be given the density, or unless you're being asked to calculate the density.
Thank you.
Other questions about this? Okay. I am going to briefly get into, because I don't know that I'm going to get to. We're briefly going to get into the periodic table today. Very brief, because I only have 5 minutes. I will tell you this, unlike me, where I record all my lectures, so if you're absent, you can still get it. If you're absent on Friday, you're going to have to come see me because Dr. DeRocher doesn't record lectures. So if I'm not here on Friday, the lecture is not going to get recorded. So you definitely want to be present for that. So I'm warning you now,